After you've kind of seen the results of what happens when you start studying intermolecular forces, and we start making a little bit more of a condensed phase, such as solids and liquids, you start getting all these unique properties of solids and liquids. Liquids have quite a few unique ones: viscosity, surface tension, and one of the more unique ones is vapor pressure. That's a very special case, and that's probably another thing completely. So let's just think about it. If you take water in a container and you allow it to start evaporating, the space above the surface of the water will start getting water molecules. That means it's a gas now, and gases impart pressures. So as that builds up, what's going to happen is these particles floating above the water can go back into the water unless they're whisked away. So if you put a lid on the container, all the particles are trapped, so the water starts going back into the water phase, or I should say the water vapor goes back in. As this happens, you finally reach a state at which the exiting evaporation rate equals the entering condensation rate, and you reach what we call equilibrium. So when those two rates equal, you establish a constant pressure inside your container. And that pressure is called the vapor pressure of that liquid. In the case of water, you would say it's the vapor pressure of water. It's an example of what we call dynamic equilibrium, meaning when you look at the thing, you can't tell anything's happening, but in actuality, there are billions and billions of molecules leaving the surface of the water, and there's also billions and billions re-entering, and they are exactly the same rate, so there's no net change, but you have established what we call a vapor pressure. And that's hopefully a little bit more of a handle for you on what vapor pressure is. We have other things to tell you later about vapor pressure in other videos.